Okay, so we are going to continue with some more addition reactions of alkenes. As we said that alkenes can have addition reaction means they can break their carbon-carbon double bond into single and then they can add something on it. So when they're going to add, addition reactions produces only one product. This is very important point. Like two of the things can add together, two of the reactants can add together. Product is going to be single, one product. Okay, in case of the addition reaction. Addition of alkene and bromine together, as we just checked that the double bond can break into single and the Br2 can add on one bromine. One carbon. One carbon will get one of the bromine atom, other carbon will get other of the bromine atom. So like this addition
Miss,
of can happen. Yes.
Miss, so basically, in addition reaction, only one product is formed. So basically, a
Yes.
pure substance is formed, a pure
A
one,
pure
right?
substance is going to form. Yes. In case of the addition, only single product will be there. Okay. So that is going to be pure as well. And if for this specific reaction, we have the color change as well, which is very important to remember that orange color will go to colorless at the end of the reaction. So this is one example of addition reaction. We have some other reactions as well, addition of hydrogen. Alkenes can also break the carbon-carbon double bond and add hydrogen on it. So carbon double bond will break, both the carbons will get one extra hydrogen like this. So if you see, after adding hydrogen, this alkene is basically changing into alkane. So this is basically a method to prepare alkane from alkene. If we have ethene, it will make ethane at the end. If we have propene, it will make propane. Pentane, it will make pentane. So whatever alkene we have at the start, it is going to add hydrogen and give us the same carbon number alkane at the end. Okay, so this reaction is known as addition of hydrogen reaction, and this reaction need a catalyst as well, nickel catalyst to proceed the reaction. So nickel catalyst is needed to for this reaction. Then some other addition reactions are possible as well. Like we can add water, but we are going to add water in the presence of some heat. So we can say addition of steam basically. Okay. So we can have carbon-carbon double bond. Steam means the water in the gas form in the presence of some heat is going to add. Water is basically HOH. Means one of the carbon can get H after breaking the bond and one of the carbon can get OH at the end. So like this the water is going to add. One carbon H, one carbon OH. And for this we need some catalyst as well. Catalyst is acid. Acid catalyst is needed to proceed this reaction. And this reaction also need 300 degrees Celsius temperature and 60 atm pressure. So temperature and pressure and catalyst, all the three things are needed for this specific reaction. This is basically addition of water reaction. So it is known as hydration reaction. Okay. The previous reactions also have a name. Let me tell you the name. Whenever we do any addition reaction, we write Asian word at the end of the reaction for all the addition reactions. Let's say we are going to add bromine on the alkene, so we can say it bromination reaction. Bromination, as I told you, write Asian at the end. So bromination reaction means addition of bromine. Okay. Same way, when we are going to add hydrogen, so that is going to be known as hydrogenation reaction. Means addition of hydrogen. And when we are going to add water, water means hydro. So we can say it hydration reaction, addition of water. So Asian word will come at the end of all the addition reactions. Okay. So conditions are very important to remember. In case of the bromine, there is no specific condition, no catalyst, no heat is needed. It is going to happen at room temperature, normal temperature. In case of the hydrogen, nickel catalyst is needed. Not only nickel, platinum, palladium, some other possibilities are there as well. So nickel is fine, which is written in your syllabus as well. A nickel catalyst is needed. In case of the water, Heat is needed, so we can say it's steam addition basically. So catalyst, temperature, pressure, all the three things are needed. Now let's see. We are starting with alkene and it is going to end up with alcohol. So this is basically a method to prepare alcohol. If they ask you to make ethanol and suggest which reactants can make ethanol, so you can say, okay, take ethene, do the addition of steam, it will give you ethanol at the end. So this method is changing the alkene into alcohol by addition of water. Okay. So any number of carbon having with alkene, we can change into that respective carbon alcohol. Okay. Okay.
Miss,
Yes. Any question here?
Miss, I have a question. For like we told that for the addition reaction we add the word Asian. For like alkenes and steam, will we add Asian
Hmm.
or no?
No, no, we added. What you said again, your question is?
No, miss, like for addition reaction we add the word Asian. For
Hmm.
alkenes and steam, do we add the word Asian or not?
For the alkenes and alkanes?
Alkenes and steam.
Yes, yes. That is basically steam is water. For water, we use the word hydro, basically. So
So that should
hydration.
be hydration. Okay, okay,
Yes, yes.
hydration. Right.
Hydration. It's written here. It's hydration reaction. We can add chlorine and other things as well. If we add chlorine, it will be chlorination. Bromine, it will be bromination. Hydrogen, it is hydrogenation. Water or steam is hydration. So very important thing that in the exam, if they ask you, hydration means that is water addition. And hydrogenation means that is hydrogen addition. So words are little different from each other. Okay. Yes, Wafia, you were raising hand. Any question? No question here. Yes, Samreen.
Miss, here in the acid catalyst, it's written H3PO4. What is that?
That is basically
Do we
phosphoric
have to
acid.
remember the symbol?
Yes, yes. Acid catalyst you have to remember. You can remember H3PO4. Some other acids we can use as well, but it's better to just remember the same. That will be easy to remember. Okay.
Okay.
So acid catalyst is needed to proceed the reaction forward. Yes, Wafia?
Miss, which acid is H3PO4?
It's phosphoric acid.
Oh, okay.
Phosphoric acid. Okay. Okay. Let's move forward. Okay. After alkenes, now we can move towards alcohols. A little introduction of the alcohol is already done that they are also one of the homologous series with the functional group OH, which also called hydroxyl functional group. They have the general formula CnH2n plus 1 OH. Any number of n value we can put starting with 1 and we can get the formula of alcohol at the end. All the alcohols are different from each other by one CH2 unit. It means if you just write their formulas, all are going to be different from CH2. You can add CH2 in the formula, it will become the next alcohol, means C2H5. Then you can add one more CH2 in the formula, it means the next formula you can get. So all the formulas are different from each other by CH2 unit. And we can just name them as well, displayed formula. These things are already done in previous topics. So now we are going to move toward the alcohol, some uses, methods, and reactions. Okay, ethanol is one of the alcohol with two carbons, and this is the most important alcohol, C2H5OH alcohol. And we can even write its structural formula means all the carbon separate, CH3CH2OH or C2H5OH, both are basically ethanol. Why this ethanol is important alcohol? Because it is basically used in all the alcoholic drinks. So it is very useful alcohol. It is also used as a fuel in cars and it is also used as a solvent to mix some of the organic products. Okay. So solvent means
Miss,
something. Yes, Luna.
Miss, you meant by all the alcoholic drinks by the ones which are used in the medical field, right? Like
Yeah,
maybe
maximum of the alcoholic drinks are basically having ethanol. Alcoholic means having alcohol inside.
yes.
So 2-carbon alcohol, ethanol is basically present in alcoholic drinks.
Yes, but so I meant by they're used in the medical field.
Yes, in the medical field. Yes, yes, in the medical field as well.
Yes, that's what I meant.
Hmm. And then this ethanol is also used as a fuel for car and as a solvent as well. And ethanol, okay. Now, just like the simple alkanes and alkenes, ethanol can also go undergo complete combustion reaction. Means it can burn with oxygen and it can give us carbon dioxide and water at the end. We have to write excess oxygen whenever we are going to mention about the complete combustion because we know that incomplete combustion is giving us a different product. To make the ethanol, there are two different methods. This is very important exam question uh, for the method to prepare the alcohol. There are two different methods to prepare the alcohol. Number one, that we just said above, that you can take alkenes, okay, and you can add steam to it. It will give you ethanol at the end. So because we need ethanol 2 carbon, so we can take 2-carbon alkene, ethene, do the addition of steam by hydration reaction and get ethanol. This is the same method we said above. Second method to prepare the ethanol is fermentation of the glucose. We'll talk about the detail of this fermentation. Both these methods, the method number 1 and 2, have some advantages and have some disadvantages as well. So we will see the detail of this method. Then we will see some advantages, disadvantages, comparison between two methods. Both the methods separately can come in the exam. Comparison can come in the exam. They can ask you advantages and disadvantages of both the methods. So this is very important exam question. So let's talk about the first method, hydration of ethene. For hydration of ethene, as we said that we are going to take the hot catalyst phosphoric acid. The formula was given above already, H3PO4, phosphoric acid, 300 degree temperature, 60 atm pressure, and we are going to take ethene adding the water, so it is giving us ethanol alcohol at the end. Okay, this is the first method that we can use. Okay, because temperature is too high, it means we are going to get gaseous ethanol at the end. Because temperature is very high, a gas will be collected. This gaseous ethanol we can pass from condenser, or we can just condense it and we can get into in the liquid form that is usable further. So gas can be collected, then just convert into liquid according to the use. Okay, this is the first method, easy. Check out the second method to prepare the ethanol. That is fermentation of glucose method. In this fermentation reaction, we are going to take sugar or starch from the sugar cane. Means this method will start from the plant. We are going to take the sugar cane. Sugar cane has sugar or starch inside. Okay. We are going to dissolve this sugar or starch in water and yeast. Okay, dissolve in water, then add the yeast in it. I hope you guys know about the yeast. Yeast is an enzyme. It contains some enzymes inside. Anyone, if you remember from biology, can you tell me what is an enzyme? What is the function of enzyme? And why we are using enzyme over it? Any idea? Okay, yes, Wafia, and then Luna as well. Yes, Wafia, you want to tell? Unmute your mic. Okay, Jude. Jude, you want to tell? What is an
Yes,
enzyme?
miss.
Why we
So
use enzyme in reactions?
basically, enzymes, we use them to like make the reactions faster, and it's used even inside in our body, in all the systems inside our body to help the reactions.
Okay, right.
Miss,
Yes, Luna.
I want to say the same things but like more biology.
Mhm.
uh
enzymes are like biological catalysts.
Hmm.
They are used in our body to speed up the reaction they're usually for digestive systems, for digesting our food, breaking it down into much simpler pieces so our body can work with it and give off in our body energy as fast as possible.
Right, that is fine. Yes, Samreen.
Miss, enzymes are biological catalysts. They will speed up the reactions in our body, and
Hmm.
there are also like some there are enzymes that will be sensitive. So you can say like if the temperature is too high, they can become
Hmm.
denatured.
Right, very
So
good
they need
point.
an optimum temperature
Hmm.
for them to work. An optimum temperature is that when they have the best temperature at which they work and gives a high
Hmm.
reaction.
Okay, right. Okay, very good, Jude, Luna, and Samreen. All the answers are correct. So, yes, enzymes are basically biological catalyst. Like they are going to work as a catalyst. They're going to speed up the reaction. So, we are going to use the yeast over here, which contain enzyme to speed up the reaction to do the breakdown of the starch or the glucose into much simpler starch or the sugar into much simpler glucose, basically. Okay. So, and as the Samreen mentioned about the temperature, yes, enzymes have a specific temperature value where they can work. They cannot work at very low temperature because their reaction will be very slow. Their working will be very slow. And they cannot work at very high temperature, they will break down. They will denature. They are going to work at optimum moderate temperature. Okay, so same thing we are going to
Miss,
discuss over here. Yes?
do you mind if I add something?
Yes, sure, Wafia.
Miss, along with an optimum temperature, enzymes also have an optimum pH.
That's very
So
good. Mhm.
every enzyme has like a specific pH value at which it works best.
Right.
And there are
Optimum
some specific
temperature.
and
Mhm. Yes, yes, sure. Continue.
there are some specific enzymes that break down like break down a mixture of substances, and there's some enzymes that make up a new
Hmm.
substance.
Right.
So
Very
yeah.
good. So they are going to be used up in both ways to break or to make as well. And optimum temperature and optimum pH. Both ways we have to check that we need a specific pH and specific temperature values to use the enzymes. If you're talking about the enzymes that are used in the body, so they are going to work around neutral pH and body temperature. But for chemistry
Miss,
reactions, they will be having different pH and temperature values. Yes, Luna.
for biological enzymes in our body, um uh, uh, they vary in different parts of the body depending on the needs. For example,
Hmm.
for the what we can say for the stomach, for the enzymes, they usually have they
Hmm.
can tolerate high temperature, so they will be able to give
Hmm.
us more
Right.
energy.
Yeah. According to the point or the place where they have to work, they will have different temperature and pH values. Okay, right. So let's come back to the topic. So basically, we are going to collect the sugar or starch from the sugar cane. We are going to dissolve it in water in the presence of yeast enzyme. Yeast enzyme is going to catalyze, means speed up the reaction, which is the breaking down of the starch or sugar into smaller glucose molecules. Okay, because we need this glucose basically to make ethanol. Okay, and this reaction we have to do in between 25 to 35 degrees Celsius, which is the best temperature for the yeast enzymes to work. And this reaction we have to do, very, very important point, in the absence of oxygen. We cannot do this reaction in the presence of oxygen, because in the presence of oxygen this is not going to give at the end glucose or ethanol, the final thing. It will have different products. It is not needed for this topic right now, so I'm not telling in detail. But if you take presence of oxygen, the products will be completely different, which are not needed here. So we are going to do this reaction without oxygen, means in a closed place, in a vacuum, create a vacuum in a room or in a hood, a fume hood, and then do this reaction. So in the absence of oxygen, we have to do this reaction for a few days. So means it will take time to do this reaction. Temperature should not be very low because reaction will be very slow. It should not be very high because the enzyme will denature at high temperature. And absence of oxygen is needed for the yeast to respire, because they respire anaerobically. N means no. So aerobic means oxygen. So no oxygen means in the absence of oxygen, they are going to produce, they're going to use the glucose, and glucose will break down into two products. It is going to give us ethanol with carbon dioxide. This balanced equation is very important as well for the exam. And after that, one more important point, as soon as the glucose will start breaking and giving us this alcohol, ethanol, as soon as you get 15% concentration, what will happen? This yeast, which is used up in the reaction, will get killed. Means you're getting the product. If the product concentration increases more than 15%, means it will be dangerous for the yeast to work. So what we can do, as soon as your alcohol concentration reaches near 15, remove it. Then do the reaction again. It will again start with 1%, 2%. As soon as it reaches near 15, remove the alcohol again. Then do the reaction again. So you have to do this reaction again and again, start it again and again, because more than 15% is dangerous for the yeast. So this process, which we have to start again and again, we have to stop the process, remove the product, do the reaction again, start it again, then remove the product, start it again. So this type of the reaction is known as a batch process. Batch word is opposite of continuous process. So it's not a continuous process, it's a batch process. Okay. Now any question till here? Raise your hands. If there is no question, lower your hand. If it is raised from previous. Yes, Luna.
Miss, it might be a stupid question, but Miss,
Mhm.
for the temperature or the room temperature, if we increase by 1 to 3 degrees, will it affect or will it become a little bit slower?
It will affect definitely. If you are going to take less than 25, then it will not take few days, it will take many days. More than 35, it will start denaturing the enzyme. So 25 to 35 is the range that we can use in between.
Mm.
Okay. So less than 25 will make it more than few days. More than 35 means the enzyme will start denaturing. Its reaction will not be as effective as we want. Okay.
Miss, for the batch,
Yes, Luna, more
for
questions?
yeah, only the last one. For the batch process, I couldn't really get the point for the batch process.
Batch means not continuous. It means if you're going to start the reaction, it will happen till the end without break. No, this reaction is happening with breaks. You're going to do the reaction, 15% product means you're going to stop the reaction for some time, collect the product, then start it from zero again. Then the reaction will happen, make 15% product, then collect it, then do the reaction again. Means it will not give us 100% product in one flow. It has to stop the reaction after few percentage of the product, then have to start again. So it's a batch process with breaks. Okay. Yes,
So, Miss,
Samri?
it's a problematic process.
Yeah, it's like time taken, but it has some benefits as well. So we'll see what are the benefits of this reaction. Okay. Okay. Yes, Samreen, your question now.
Miss, so basically, so for every for the fermentation of glucose, we just need batches to prepare it, right?
Yes, we have to do this in batches, in steps, again and again.
So if we not do batches, then the fermentation of glucose will not be done.
If there is no batch, no. If we are not going to stop the reaction, as soon as there is 15% product, the enzyme yeast will get killed, reaction will stop. You will not be able to get 100% product. So if you want to stop this yeast to be get killed, you have to remove this product, and then you have to like means break the process for some time, stop it, then do it again. Only then you will save this yeast. Otherwise, the yeast will get killed.
Okay.
Okay. So now let's see a comparison between these two methods. As we said that both the methods will have some benefits and some drawbacks as well. Okay. In case of the hydration of ethene and fermentation, both the methods are here. For the equipment, hydration of ethene needs a complex equipment or setup to do the reaction. Fermentation needs a simple equipment. Okay, no need to remember what type of the equipment is needed, just simple and complex. Raw material means the starting material to start the reaction. For ethene, hydration of ethene, we are using ethene from the crude oil. Means it is a non-renewable reactant. It's a non-renewable resource which can finish after some time. But for the fermentation process, we are using sugar or starch from the sugar cane, which is a renewable source, means we can grow it again and again. We can use it again and again. Okay. Type of the process, the hydration of ethene is going to be a continuous process, means once we start the reaction, it will happen till the end without any break. But the fermentation is going to be a batch process, means every time we are going to mix them, we have to just stop the reaction, collect the product, then do it again. So we have to repeat the process after a few days again and again. So it's a batch process. Hydration of ethene is going to happen quickly. So rate of reaction is very fast. Speed will be fast. Fermentation is very slow. It takes many days to happen. Quality of the product. After, at the end of the hydration of ethene, the ethanol that you are getting is going to be pure. But in case of the fermentation, because we are mixing water at the start, we are going to dissolve the starch or the sugar in water. Means we are not getting pure ethanol at the end, we are getting diluted form of the ethanol with mixed with water. So it is going to not give us pure ethanol, but it is giving us very dilute solution of ethanol. Okay. Then hydration of ethene is not producing any greenhouse gas. So that is a benefit as well. No greenhouse gas like carbon dioxide or something is produced. Okay. But it will produce some of the pollutants because we are taking the crude oil and the fossil fuel. So some of the still some of the pollution will be there, but not much. In case of the fermentation, it is clearly producing carbon dioxide, which is a greenhouse gas. Okay, that is one of the drawback as well. In case of the hydration of ethene, very high temperature and pressure is needed. So high temperature and pressure means energy cost is going to be more to do this reaction. And in case of that is the reason the setup is also complex, because for high temperature and pressure, we need little expensive and complex setup. Okay. Fermentation process needs only 25 to 35, very low temperature. So it's easy to achieve in simple equipment as well. So this is a comparison table between two of the methods, and all these points are very important to remember. Any question till here? Yes, Amreen.
No. Miss, for the batch process, how many batches do we need?
Uh, it depends how much ethanol you want at the end. Okay.
Oh,
Every batch is going to give you 15% concentration of ethanol. As much ethanol as you want or as much reactants you have at the start, you can keep going with the batches. Okay.
oh. Miss,
So
okay.
number of batch will depend how much reactant you have or how much product you want at the end.
Miss,
Hmm.
if you ask me which of the two processes I will use, it will be none of them. Because first
You
of
will
all,
say
I'm gonna
both
put
have
on,
some advantages, disadvantages. So we cannot say which one is best. Both have
yes,
some advantages, some disadvantages at the end.
first of all, if I pay too much, I will lose my life. And if I didn't pay, I will also lose my life. So
Mhm.
none of them is more.
No, both are useful somehow. Both have some benefits. So hydration of ethene is not a good process if we talk about the non-renewable resource. But it is a good process because it is not giving any greenhouse gas in the atmosphere. So this way we can just see a very big difference. We have some very serious environmental issues in one process, but in other process we have the renewable resource use. So both have some benefits and drawbacks at the end. Okay. Okay, moving to the next homologous series about carboxylic acids. A little introduction is already done that they are going to have COOH in the formula, right? This is a homologous series which has COOH carboxyl group in the formula. Anything on this side can be attached, like 1 carbon, 2 carbon, whatever. So we can say it R group. R group means any carbon number can attach over here. But this side is always going to be COOH. Carboxylic acids are going to behave like simple acids. Means all their reactions are same like simple acid. So simple acid reaction we have done already 3 types of the reaction. Simple acids can react with metals. They can produce salt and hydrogen. Acids can react with carbonates. They give us salt, water, and carbon dioxide gas. Acids can react with bases. Then they produce salt and water, which is a neutralization reaction. Acid and base giving us salt and water. For the carboxylic acids, when they react with when they are producing salt, in all the reaction they are producing salt. So when we want to name the salt, we are going to write NO8 at the end of the name. For example, we have methanoic acid. When it will react with the methanoic acid, when it is reacting with metal, maybe with carbonate, maybe with any base, it has to make this product, right? Salt with something. Salt of methanoic acid will have a name methanoate. So take the methane from the name. In place of the oic acid, you are going to write NO8 like this. So methanoate. So just add this at the end of the name. So all the salts of the carboxylic acid will have NO8 at the end of the name. Ethanoic acid name will be ethanoate when it will convert to the salt. Let's see some of the reactions, then it will be more easy, more clear to you. Let's say we have ethanoic acid. It is going to react with the metal magnesium. So ethanoic acid means CH3COOH, 2 carbon carboxylic acid. It is reacting with magnesium now. So it's very important to write the formula of the salt. Magnesium is a metal, means it will produce salt and hydrogen. First of all, this thing you have to remember. What is going to be the formula of the salt? This thing is very important to check. Salt and hydrogen. Okay, remember from the carboxylic acid, in place of the hydrogen, metal has to come and do the substitution. So if you take the ethanoic acid CH3COOH, when it has to remove the hydrogen, hydrogen is positive, means this remaining thing is going to be negative. CH3COO -1. Why? Because hydrogen is +1 in the formula. Now, in place of this one, this hydrogen, you want to add magnesium. Okay, I'm telling you how to write the formula basically. Magnesium is from the group 2, means +2. Now, if you want to add these two together, what will happen? This 2 will go with this part, and this one will come with magnesium. So this CH3 COO will go in a bracket, 2 outside with magnesium. Means 1 magnesium will take CH3COO -2 to make this salt. That's how you will get the salt formula. Again, I'm telling, because this CH3COO is taking 1 hydrogen over here, means it is -1. 1 magnesium will take 2 of these to make a formula. According to the ionic formula writing, we can easily get the formula. Okay, but if you have a group 1 metal, over here in this example, this hydrogen has to replace with the potassium, let's say. So CH3, CH2, COO negative. Potassium is from the group 1, it has +1 charge. Now both are 1 1. Nothing will outside the bracket will come, so it will just combine together and that's it. So the formula will be CH3, CH2, COOK. In summary, if you don't want to do this whole thing, no need. In summary, you can remember whenever you have a group 2 metal, 2 of the things will come in the bracket. And whenever you have a group 1 metal, only 1 is needed because charge is same, +1 -1. Okay, whenever you have a group 2 metal, 2 of the acids will come and 2 will go in the bracket. And whenever you have a group 1 metal, in that case, only one of the acid will be needed because charges are same in that case. Okay, I hope this point is clear to everyone. Any question from this one? Or it's clear? Yes, girls. It's clear?
No, Miss, is clear.
Okay, right. Okay, so this first equation is basically a reaction of acid with metal. So it is producing a salt with hydrogen gas. Then this carboxylic acid can react with the base as well, like potassium hydroxide. And when acid and base react together, that is going to be a neutralization reaction, means it is producing a salt with water. And writing this equation is very important. Balancing the equation on both sides and getting the right product is very important. Okay. This carboxylic acid can also react with the carbonates. When they are reacting with the carbonates, we know that it is going to produce three products: salt, water, and carbon dioxide. Again, the salt formula, just replace this hydrogen with whatever metal you have and then balance the equation on both sides. Okay, if it is group 1 metal, then only nothing will go in the bracket, it will be only one thing with the metal. If it is group 2, then metal will have two of the negative parts in the bracket, only then the equation will be balanced. So practice writing these three types of the equations with the metal, with metal hydroxide, and with metal carbonate of group 1, group 2 only. So these are going to be the reactions for the carboxylic acid with the metal hydroxides, bases, and carbonates. Okay.